good to be here today. I'm going to do a basic introduction about what blockchain is, and then I'm going to try to explain why it's going to be so important. So this should be a pretty simple introduction about blockchain, and then towards the end, I'm going to talk about some more complicated ideas. So I'll go ahead and get started. This is a famous American, Don Tascott, and he said the blockchain is an incorruptible digital ledger of economic transactions. And I want to focus in on that, the words incorruptible digital ledger, because that's essentially what the blockchain is. It's a new kind of ledger. It's a new kind of database that the world has not seen before. And I'm going to explain a little bit more why later on, while this idea of a new kind of database is so revolutionary. And then we'll be able to go into deeper. Okay, so what do you know about blockchain so far? Why would you be interested in a blockchain talk? Well, for the most part, we think that blockchain is about money, right? Lots of money, and how much money has been involved in blockchain. So if 3 years ago you invested $1,000 into Bitcoin, you would have $32,000 today. That's in 3 years, 1,000 to 32, amazing, absolutely amazing. There's another technology called Ethereum. If you 3 years ago invested $1,000 into Ethereum, you would have $600,000 today. It's a lot of money. Another technology, one of the technologies that I work with is called NIM. If you invested $1,000 in NIM 3 years ago, you would have $1.4 million today. And if you just didn't invest in anything, you just kind of randomly invested in lots of different things, an index. If you had an index investment, $1,000 3 years ago, you would have $200,000 today. Now, these are ridiculous numbers. These are crazy numbers. This is not normal kinds of money that we're talking about. But I do believe that this money reflects what is happening in blockchain. It does reflect the amount of change that blockchain is going to bring into our world today. And so I'm going to try to explain about why that's so important and how it comes. So I'm going to go back to the beginning, 1960s, 1950s in America. Computers had come, hardware had come, and in the 1950s and 60s, software developers started to make databases. And those databases in the 1950s and 60s were very, very simple. And it was just a database for storing information. And by the 1970s, the databases had started to get use in businesses. And by the 1980s, those databases were actually really big. Companies like IBM had been selling databases to lots of big countries and big companies all over the world. By the 1990s, of course, databases had become everywhere, and they were running lots of aspects of our lives. Now, the important thing is that the internet was growing at the same time too. It was later. The internet didn't start in the 1950s, it started in the 70s and the 80s, and then it got really big by the 90s, but databases were already big in the 80s. And the typical kind of storage thing that we would do for a database, if we wanted to protect our information, is we would put a password on that database. That's it, a password. And that was all the security you needed, was a good password. But the internet came after databases. And this is what happened with the internet. Internet made a new kind of system. And the system was you had clients, which were computers. They connected to a server on the internet, and that server connected to a master database, and it was a copy. And people still used a password to protect that database. And this is what we call a centralized database. It means one person, one database, one control point. And they put all the information in that database. Now the problem was, that it was protected with a password. And when the internet came, these databases were connected to the internet, and that means anybody who could guess the password could get into the database. And this is a problem, because in this database, they put your identity. They put your money from your bank. Your bank uses a database, it's protected with a password. Your country uses a database. Your identity is protected with a password. And hackers started to use the internet to guess that password and get into that database. And they're causing all kinds of problems. Now, the blockchain is different than this model. And that is because the blockchain was born after the internet, not before the internet. And instead of the internet being a problem with databases, the internet is actually the security of the blockchain. In fact, without the internet, there is no blockchain. And so we use the internet as a way to protect ourselves. So how does that work? Well, this is basically kind of what a blockchain database system looks like. The servers are everywhere. In the traditional model, we have one database. In the blockchain system, we have a database, a database, a database, a database, a database, and a database. We have a lot of databases. And those databases are repeated over and over again. So now an attacker cannot just hack one database. Because one person you can attack, but with a blockchain, if you attack one, there's still another one, and another one, and another one. If you attack two, if you attack three, there's still 100, there's still 1,000. In the blockchain world, we have thousands of servers, and you can take down one, you can take down two, but you cannot take down them all. It's impossible. And the internet gives us security. And instead of there being one password, now, everybody has their own password. You have your own password for your data on the blockchain, and you own that little part of the database. And only you can edit it. And so this is what's so powerful, is that the databases are spread out, and power to read and write to that database is now given directly to the people, to you. And that's the revolution of the blockchain. I'm going to talk a little bit more about how this is changing our lives. I'm going to cover some basic points and what it does. First of all, the blockchain uses cryptography. This is why we say cryptocurrency. It uses very advanced mathematics to secure itself, and this gives us security. And actually, there's nothing new about cryptography. We use a lot of cryptography already. And we use this today. When you log on to a website, that's cryptography. When you enter your PIN number into an ATM machine, that's cryptography. When you send a text message on your phone, that is using cryptography. It's securing everything. And so it uses that security, but it's a different database system. So we use security, but it also, the blockchain brings a new model of security that the old model of security doesn't use. And we use cryptography in a different way than it's ever been used before. And this is called the block. The block in the blockchain. It's a new kind of way to use cryptography. And Bitcoin is the first blockchain that made this famous, and it did it with something called proof of work. And a lot of people don't quite understand proof of work, but I'm going to try to explain it today in a very simple way so that you can understand it. And I'm going to use a nice example of an ant, okay? So here's my ant. This is an ant, and it's walking along. And this here is some tree sap. Some tree sap that has fallen from a branch. It's on the ground, and the ant walks into that tree sap. Now, the ant can get stuck in the tree sap, right? And if that ant gets stuck in the tree sap, it may or may not get out. And this is like an ant on the blockchain is like a transaction. And some sap is like a block. And one block in a blockchain is not very secure. One block in a blockchain may mean that your transaction is good. It may mean that your transaction is not good. But just like a tree can drip more sap, then another block can come along and add more sap. And it uses cryptography to build on the old cryptography. And then another block comes and adds to that cryptography. And then another block comes and adds to that cryptography. And then another block comes even after that. And the more blocks that come on a blockchain, it's like more sap dripping on an ant. And eventually, that ant can never escape. And eventually, that ant will be in the sap forever. And this is like amber. Like you can find a fossilized ant that fell into sap from 100 million years ago, and it became a fossil. That's like blockchain. When you have lots of blocks, you have something that is guaranteed to last forever. It uses a lot of cryptography, and you can't undo this cryptography. It makes it very secure. So what else is blockchain? It's decentralized, and decentralized is that graphic that I showed where the computers are all over the world. And that's one of the things that makes it so powerful, is that you cannot attack it. When people ask me, where is the blockchain? Where is your business? And I say, where is the internet? Can you take down the internet? Can you stop the internet? The internet is just a bunch of servers run by people all over the world hosting websites and hosting services. That's blockchain. It's servers all over the world hosting services. And just like you cannot stop the internet, you cannot stop the blockchain. And that decentralization of all those servers gives us trust. And this is really important because it's for the first time ever, and I really, really, really mean this, it is the first time ever in the history of humanity that we can have something that we can truly trust as a ledger, as a technology that we can really trust. Because before, when you put money in your bank, that bank can take your money away. Before, when you wrote something, somebody can delete that or undo that. But now, when you put something on the blockchain, nobody can take it away. And I can see that my friend sent me money. And my friend can see on the blockchain that they sent me money. And I can see that my friend can see me. And my friend can see that I can see them. And all of you can see that we traded money. It's very, very, very trustworthy because everybody knows what happened. And this can fundamentally change the way that things are happening. It is an open ledger. Open means that all these servers on the internet are willing to share their data, are willing to communicate. It means that anybody can look at the full history and can see everything that's ever happened. Now that doesn't mean that it's always very transparent. So for instance, I can send a message on the blockchain to my friend. It's an encrypted message. It is not very visible. The numbers are visible. The transaction is visible, but the words have been encrypted. Now I can send a plain text message and somebody can read those plain text messages, or I can send encrypted. Now, nobody knows what I said, but everybody can agree that I said something if it's encrypted. And if I want to show people the original words, then they can look on the blockchain and they can see, okay, that was exactly what he said and he can prove it. So it's very open. And that brings us access to new markets. This is a little bit confusing, but having this open, this decentralized technology, it allows us to do things that we would have never done before. And the first kind of examples of blockchain are not very good examples. Actually, it's a little scary examples how blockchain started. In fact, maybe 4 or 5 years ago, 6 years ago, if you looked at Bitcoin, 90% of Bitcoin transactions, more than 90% of Bitcoin transactions, were used for illegal things, for things that we wouldn't really want people using the internet for. Today, more than 90% of blockchain transactions are good transactions. So there's been a giant shift and people have adapted this technology. There's a famous story in Bitcoin about something called the Bitcoin pizza. So many years ago, one person paid 10,000 Bitcoins for a Bitcoin pizza. 10,000 Bitcoins, it's a fortune. If you had 10,000 Bitcoins now, you could be living on your own island. And this guy spent that many Bitcoins just to buy a pizza. But in reality, that was just a joke. He was just playing around. It wasn't real money. It wasn't a real transaction. What happened with Bitcoin is that there was a website after that. It was called the Silk Road. And that website sold drugs. And that website was not necessarily the best website. But it allowed people to use Bitcoin for real money. And that was the first time that people really understood that an open, decentralized ledger that was using cryptography could really be used for money. It wasn't necessarily good money, but it was money. There were people really exchanging goods for services. So that was the pretty amazing thing about that. Now we know that most of blockchain is a very legitimate service and that people use it for good ways. How did it start? It started with this guy named Satoshi Nakamoto, 2009, and he wrote this white paper. It's called the Bitcoin White Paper. It was a really amazing white paper. But the thing that he was able to solve, the thing that he figured out that nobody in the world before him had figured out, was he was able to solve a problem called the double spend problem. And this is what makes blockchain so powerful. And this is a little bit funny because blockchain's amazing breakthrough is not what you can do with it, it's what you can't do with it. You can't send the same thing twice. Let me explain what that means. If I have my phone, I can take a picture. I can send a copy to my friend. I can send a copy of that picture to my mother. I can post a picture on Twitter and share it with thousands of people. I can send that picture as many times as I want. Nobody can stop me. But on the blockchain, if I send a piece of digital information, if I give my Bitcoin to my friend, I cannot send it to another person, or my friend, or put it on Twitter. When I send a digital piece of information like a Bitcoin to somebody else, it now becomes theirs. And this is really cool because before Bitcoin, you couldn't do this with digital information. Before Bitcoin, digital information could be shared freely with everybody. And now we have a way of definitively saying, this one belongs to Jeff, this one belongs to Andy, and this one belongs to Billy. And it's very clear. It's a ledger of truth. And this is changing the way we can do everything. Now, when Bitcoin started off, it solved this problem of the double spend. And Bitcoin was basically designed to do one thing, and that was to send Bitcoin. That's it. That's all Bitcoin does. Now, a lot of people tried to build on Bitcoin. They tried to do amazing things on Bitcoin, but it was really just designed to send Bitcoin. That's it. Then later on, somebody decided, wow, this blockchain is amazing. What else could we do with it besides send Bitcoin? And along came a platform called Ethereum. And Ethereum is designed to send ETH. ETH is a currency. It's like Bitcoin is for the Bitcoin network. ETH is for the Ethereum network. That's the coin that lives on Ethereum. And ETH is designed to send ETH. So it has a nice blockchain network, but it has something else. Ethereum also has a virtual machine, a VM, a virtual machine. On top of the blockchain, they built a whole operating system, It's amazing. You can write applications, you can launch software inside of this virtual machine that is built on top of the blockchain. It's revolutionary. And how do you power the virtual machine? You use gas. Where do you get gas? You get gas from ETH. So you turn your ETH into gas, you use the gas to power the virtual machine, and that's how people get paid for running your program. And you can literally put Windows on top of Ethereum, or you could build a calculator on top of Ethereum. It would be incredibly expensive. It would be very hard to do. And it would cost a lot of money, but you could do it. You literally could build anything you want. In reality, most people just use Ethereum for the most simple and the most basic applications. And we call those smart contracts. Now, the good thing about a smart contract is, for the first time ever in the history of the world, you can write a program and nobody can turn your program off. Up until now, if you had a program on your computer, somebody could kick in your door and they could turn your computer off. Or if you were hosting it on a server, somebody could go in and pull the power for that server and then your program would go off. But now you can write and deploy a program into the cloud and it literally will never be turned off. It will always exist. And that's a beautiful thing. But the problem is that because of the way that Ethereum works is that once you write a program, you don't get to edit it. Because if you could edit it, that means you could turn it off. So you get one chance to make your smart contract correctly and put it in the virtual machine. And this is a problem because, as it turns out, most applications in Ethereum, even the most simplest ones, end up breaking. Just like any other software. When Windows made Microsoft Word, was it the perfect Word? Or when Apple made the first Apple OS, was it perfect? No, they all had bugs. And it takes a long time to make those bugs go away. Well, it's the same thing with Ethereum. All these contracts keep on having bugs. So NIM, the project that I represent, does things a little bit differently. Instead of making a virtual machine, NIM's architecture is to make the database. Remember the original Bitcoin database? NIM makes the database, and it makes the original database a smart database. There's no smart machine, there's no virtual machine, it's just a smart database. So NIM uses plugins. And we have a plugin into the database directly for assets, for creating your own coin. We have a plugin directly into the database for certificates. We have a plugin directly for voting. We have a plugin for ID, or we have a plugin for IoT. And these plugins work with APIs. And an API is basically the exact opposite of an application. APIs are very simple, very small, and very easy to say yes or no to. An application is a giant code that's very complicated. So smart contracts are very complicated. APIs, which is what NIM uses, are very, very simple. And developers love our APIs. At NIM, we give developers software development kits. So instead of having to learn a new language and write a smart contract, a developer just gets to use a few lines in a software development kit and create their own coin, or make their own vote, or make a smart certificate. And that's pretty revolutionary because NIM is incredibly easy to build on and very secure. The way APIs work, it's kind of like this. I'll give a simple example for everybody. When I go to my website and I go www.naver.com and I click enter, I usually get the Naver website. Or if something goes wrong, I get a page did not load website, blank page. And that's because that's an API call that goes to the internet. It's not a complicated program that's running. It's just a request and then get information back. So it's not like when I type www.naver.com, I get the web page down. No, I either get Naver or I don't get anything. That's how APIs work. That's how NIM works. When you make a smart transaction on NIM, it either works exactly as it was designed when you press enter, or it will not work at all. It's very black and white. Here's some examples of why blockchain is so revolutionary. For the first time ever, we have the promise of smart programmable money. Smart programmable money. We have smart trust. We have programmable trust. We have money that can be designed to do this or that. All other money before today was not smart programmable money. So what are some of the ways that you can program money on the NIM blockchain? First of all, it can be transferable. Transferable means person to person to person to person to person to person. It can be transferred as many times as you want. Or money can be only one-way transferable. That means Alice sends to Bob, and Bob can only send back to Alice. Bob cannot send to other people. Or you can program money to even be locked. This means that when Alice sends here, it is stuck. This person cannot return it. So you have, again, three ways. You have completely transferable to everybody, you have refundable, or you can have locked money. And this is some of the different ways that you can program money, but there's other ways. You can program money to have built-in taxes. So when Alice sends money to Bob, a little bit of money for taxes for the government automatically comes to the government. Or a little bit of taxes to the person that created that asset gets a little bit of money. It's programmable money built in. And there's other ways. You can make a total supply of currency on the NIM blockchain. You can make it fixed, where there's one amount of coins, let's say 1 million coins, and there'll never be any more coins. Or you can make it so it's editable, so the number of coins can go up and down. It's a very kind of flexible and wonderful system. Certificates are very smart. Remember how I talked to you earlier about having a photo? Well, think about a certificate, maybe a certificate of ownership of a car. The blockchain allows you for the first time ever to make a certificate of ownership for a car. And when I sell the car, I can send the certificate for the ownership of the car. Once I send the certificate to somebody else, it's theirs. It's no longer mine. I can't send the certificate of ownership here and there and everywhere. Now, right now, we use the government, and the government is a centralized authority, and the government says yes or no when you try to sell a car. If you have a lot of speeding tickets and you owe a lot of money to the government, they're going to say, no, you can't sell your car until you give us money. But on the blockchain, nobody can stop you. When you send the certificate, it's theirs. It's no longer yours. Nobody can tell you what you have to do or don't have to do. You are free. You control that part of the database. Right now, the government controls the database, and they tell you what you can and can't do. But with the blockchain, you have complete freedom to do it your way. So it's not just about certificates, it's about a lot of different things. These certificates can be owned by many different people. If I want to share the car title with my best friend or my other friends, I can do that. We can do third-party certification. We can make the government approve the certificate or not. We can make a university approve a certificate or not. There's lots of different things. We can even connect these certificates to the IoT. Here's an example. This is me. So there's this little girl in America. She saw my videos on YouTube, and she saw who I was, and she was watching me, and she decided to make a doll for me. And this is one of my companies that I helped to be a co-founder of. It's called LuxTag. And LuxTag took this doll and made a certificate for it. So now, whenever I get very old and I want to pass on this doll to my great-great-grandson, I can give a certificate on the blockchain that shows that I was the original owner of this doll. And then when my great-great-great-great-great-grandson gets the doll from my great-grandson, they can pass on the certificate. And we know exactly which certificate is the real certificate for the doll. This is a limited edition, 1 of 9 dolls. Very, very touching that she made me this doll. Not only do we have smart certificates, not only do we have smart money, but we also have smart voting, smart programmable voting. It's amazing. I'm very pleased to announce that the country of Ukraine announced that they're going to use the NIM blockchain for voting. And this article was just released today. I'm also very happy because I was the inventor of the voting protocol for the NIM blockchain. So it's very nice to see a country starting to adopt the standard that I helped to write. It was very awesome. But with smart voting, for the first time ever, you could do multiple choice voting. Let's say there's 5 candidates, and you don't want to just pick one. You could pick 2 and give half of your vote to one or half of your vote to another. Or you could pick 3. It's smart voting. You can do revoting. Let's say I picked 3 candidates as my choice, but the day before an election, there was a scandal, and a very bad video was released. And I want to revote. I can remove 2 and only have 1. And say, these 2 guys, they're in a scandal, they're very bad. Now I'm only going to vote for this person. And I can revote. We can do anonymous voting, we can do regular voting. It's a very flexible voting protocol, and it's on the blockchain. It cannot be faked, it cannot be lied, it cannot be manipulated. It's an amazing way to think about voting. We not only have smart voting and smart certificates, we have smart transactions. There's a big problem in the world. If I have money and you have money and somebody else has money, how do we trade the money? Well, in NIM, we can do smart transactions. What we can do is we can actually combine different transactions into one. Let's say Alice is going to an event, like the one today. And you come to the event, and the event owners give you some money. Let's say they give you Mon1. $10. They give you Mon1. So Alice has $10 in her account, and she sees Bob is selling coffee, and she wants to send Bob $5. So normally, in the blockchain, this would be incredibly complicated. You would have to have somebody that would register for a website like BitThumb or Corebit, and they would have to use their phone, and they'd have to use their ID, and then they would have to send money from their bank account, then they would have to change that money into coin, then they would have to withdraw the coin to the blockchain, then they could use that coin on the blockchain. On Ethereum, it's ETH. On NIM, it's called ZIM, and they would use that coin to help pay the transaction fee. Right? And it'd be very complicated, but in NIM, what we can do is the event has lots of ZIM. When Alice sends Bob $5, Ochunnen, then Alice can send the event 2 cents. And the event can send Alice 0.05 ZIM. And this is what we call a smart transaction, because it has 3 transactions, but it's actually just 1 transaction. This is a very unique thing that's never been able to be done before. To have 3 people, person A, person B, and person C, trading value all at the same time, all trustlessly, all on an open ledger, that could never be seen before. And it allows people to create coins and money, and other people that don't know about blockchain or don't know about money can now spend that money easily, instantly. It's a very powerful thing. Here's another example. We have Alice, and she wants to send money to Gongcha. There's you guys know there's a bubble tea shop called Gongcha. One of my friends has built a project called Loyal Coin in the Philippines. And he has a lot of great contracts with Loyal Coin. He has a contract with Cebu Pacific. He has a contract with the 7-Eleven. And he has a contract with Gongcha. So you can go into Gongcha, any Gongcha in the Philippines today, and buy bubble tea with his coin. And if we have Alice has DIM coin, but she wants to go to Gongcha. So how is she going to do it? She can do something on NIM, like where she can trade DIM coin. DIM coin is a very old project on NIM, for maybe Japanese yen. And this is another project that makes Japanese yen on the NIM blockchain. That company can trade Japanese yen for Gongcha points from Loyal Coin. And then Loyal Coin can then use Loyal Coin Gongcha points for 100 pesos. And Gongcha is fine with that. And so in this way, we can show from going from any currency to any other currency. I mean, it could be DIM coin directly to Gongcha, or you could put 5 people in between or 10 people in between. You can do as much trading. And again, it's a smart transaction. It's a smart transaction because all this trading is not many different trades. It's actually only one trade. A smart, programmable trade of all these different things happening at one time. It's absolutely amazing. Here's another way. We have smart account controls. We have something called multi-user, multi-sig, and you can use the user's phone. And the user's phone, usually you want to make a restore account. So let's say I have a phone and I have 100 Bitcoins in my phone. Man, I got money. But what if I lose my phone? I lose the Bitcoins. So I want to make a restore account, right? Now the problem is now if someone wants to steal my Bitcoins, they can either get my Bitcoins from my phone or they can get it from the restore account. There's two places. I have more security because I'm backed up, but now a hacker has more places so they can attack me. So how could I do this? Well, what I would do is instead of the restore account, I would make it owned by my mother and my brother. So I can spend money anytime I want, or my mother and my brother can spend money whenever they want. But maybe my mother doesn't know very much about blockchain and my brother, he's on vacation. So I want to make it maybe my mother and my best friend can spend money, or my brother and my best friend can spend money, or it takes my mother and my brother to spend money. But maybe I don't know about this best friend, so I want to make it more friends. So I have my two best friends and my brother can spend money, or I spend money. You can make these elaborate smart contracts over an account, so it's a multi-user, multi-signature account. And you couldn't do this with money before. This is smart programmable money. Imagine trying to get money in your pocket, and whenever you wanted to spend it at Dunkin' Donuts, you had to get other people to sign or not sign. Sometimes it sounds a little bit complicated, but the point is there's actually amazing things that you can do with this. And remember, it's not just about money. It can be about voting. It can be about identity. It can be about property titles. There's so many different ways that you can use the blockchain. See, actually, databases are all around us in the world today. We have databases that control tickets for events like this. We have databases that control your bank. Bitcoin showed that your blockchain database can be used for money, just like your bank uses a normal database for money. But we have databases to do voting, and we have databases to do your whole information about everything about you. When you go onto Facebook, people profile who you are, what you've done, and that's on a database which is controlled by a central authority, and they can sell your information. If the Facebook website was powered by the blockchain, nobody could sell your information. You would be able to keep it all for yourself. Here's some examples of different companies that are using the NIM blockchain to do different kinds of database activities. We're using it as a platform for loyalty points, for exchanges, for social media, for transportation, for supply chain, for education, for e-commerce, for charities, for healthcare, collaborations, the Internet of Things, marketing, augmented reality, payments, authenticity, games, system integrators, and finance. There's companies in almost every sector that are looking how they can use this blockchain database to provide new services or provide higher levels of security or give trust to their clients in a way that they were never able to give it before. It's pretty revolutionary. But here's some examples. My friend made a video game called Pac-Nem. My other friend made an MP3 store where he sells music. He calls it NIMP3. Another friend has made IoT devices that you can connect to the internet. By the way, Pac-Nem, NIMP3, IONIM, all of these are open source. All of these are available on GitHub. You can download them, deploy them, and try them out today. This is not a promise of something that's going on tomorrow or next year. This is all live code. This is all free code for anybody to use. We have ICO Maker, that's a smart contract that allows payments. We have Ninventory. This is an inventory app on the NIM blockchain. This is Landstead. This is an open source example for how a government can make citizens registered and property titles registered on the NIM blockchain. It's very fascinating. Here's another one called NIM DNS. This is a DNS service that's provided through the blockchain. So you can see, again, all of those are open source, lots of different things. But there's a big problem with the blockchain. It's not safe. Aren't you afraid? What if you invest $1,000 today and in 3 years from now you have $1 million and someone steals it? How bad would you feel if you lost $1 million? Blockchain has some big problems. It's not always safe. We need to make it safe. How are we going to do that? Well, we're using some of those advanced contracts that I just showed you earlier about making it safe. Blockchain doesn't scale. It's simple, it's true. Right now, the version of blockchain we have is a little bit like the early version of the internet a long time ago. The early version of the internet just wasn't very fast and it wasn't very powerful. And that's a little bit like blockchain today. But we're working really hard to make blockchain much faster and much more powerful. It's hard for people to start. I bet a lot of people in this room don't have any cryptocurrencies. I bet some of you, maybe you do. But one of the reasons why is it's so hard. Well, we're working on that. And is it even legal? Aren't you afraid? What if you invest in Bitcoin? What if you make a blockchain company and the government comes and kicks in your door and they try to arrest you? Did you know multiple companies in Korea have already been investigated by the police? Right? It's a little scary. So we need to know, how are we going to be legal? And we need to work with the governments. Now, in NIM, we're making something called Catapult. And this is secure and scalable and flexible. It is an amazing code. We are doing things that nobody has ever done in the blockchain before. And the developers that are making this project have a long history of doing things that nobody had ever done. This is open source. You can get it at the NIMTech GitHub and try it out today. So I'm going to go into a little bit of a techie thing for the developers in the crowd. Really quickly, what's the revolution? When Bitcoin first came out, it put all the code into one code. It was like a spaghetti code. Everything was together on one plate of spaghetti. It was just all mixed together. Now, with NIM, what we've done is we made one layer just for peer-to-peer transactions. This only processes the most important information where people are trading value. Then we have another layer where we have a MongoDB and API server. And this is very important because no other blockchain has incorporated a MongoDB for developers to get information that they need. And then we have our SDKs. And these are wonderful. We're building out lots of different SDKs and lots of different languages. So any first-year developer can make a wonderful blockchain application. It doesn't take a genius. It doesn't take a very expensive programmer. Literally, first-year developers can now develop on the blockchain with our SDKs. And finally, we have our applications, the games, the sharing apps, the things like that that are built. This is pretty revolutionary. I want to highlight one more problem, though. Blockchain started off as decentralized. And the security for the blockchain comes from its decentralization. And this is why blockchain people are always talking about decentralized. But in the past, decentralized has often meant disorganized. It's often meant not well funded, not well organized, no real leadership, no real plan for the future. But we are changing that. We are now planning very hard, we're making our way, and we are becoming organized. I want to tell one little quick story before I stop. A long time ago, when I was a young university student, Wikipedia came out. And when Wikipedia came out, all my professors at school laughed at Wikipedia. And even all my friends laughed at Wikipedia. I told them, hey, there's this new thing called Wikipedia, and anybody can write articles. And my friends thought it was stupid. And I started writing articles on Wikipedia. In fact, I started many articles on Wikipedia. And I told my friends, hey, I started this Wikipedia article, and they were like, why would you do that? It doesn't mean anything. Anybody can write anything. And I said, that's the beautiful thing. All the writers for Wikipedia are all over the world. And in blockchain, all the servers for blockchain, all the people that are contributing to blockchain are all over the world. And anybody can do anything on Wikipedia, and anybody can do anything on blockchain. Wikipedia revolutionized the way that we think about information, about encyclopedia. Blockchain is revolutionizing the way that we think about trust. Eventually, some of my articles on Wikipedia were really bad, and they got deleted. But some of my articles on Wikipedia were great, and they ended up living on, and still today, people add to those articles. It's become pretty amazing. And when I look at blockchain right now, I see that blockchain is just like Wikipedia in the early days. A lot of people think it's silly. A lot of people think it's not going to work. A lot of people say, make your own money. No, the government has to make the money. But when I was on Wikipedia, people told me, make your own article. No, only professors can write articles. I have seen the way Wikipedia changed, and I know that we are changing too with blockchain, the way the world's been built. And I'd like to join anybody to invite. We have a great community, and we have lots of ways to have you join. And just like anybody in the old days could join Wikipedia, I feel like anybody today can now join blockchain and make a wonderful difference. Thank you.